So the next aspect of magnetism that I'm going to treat now is magnetic substance. So the magnetic substance are substances that are capable of being magnetized. That is, they can be influenced by magnetic field. And the magnetic substance divided into three parts. We have diamagnetism, paramagnetism, and ferromagnetism. So let's check it. Magnetic substance. So what are the magnetic substances? They are material. They are material that are capable of being magnetized. Meaning, they can be influenced by magnetic field. Influenced by magnetic field, yes, and exhibit magnetic property. So those are the what magnetic is. And there are three types of magnetic substance. We have the magnetic substance, we have paramagnetic substance, and we have ferromagnetic substance. So if I want to explain these three substance, let me write it in full. Hmm. So I would like to explain the three of them at once. Let me create a table for it. Let me draw a table for the three of them. Yes. Permit me to draw the table like this. Good. So let me say this place is stand for diamagnetic substance. So this we do say is for paramagnetic substance. So here for ferromagnetic substance. By doing that, let me make my table in this form. So I will believe this is what? This will be the easiest way for me to what? Divine them. What is diamagnetic? Diamagnetic substance, they are weakly repaired by magnetic field. This one, I said what? They are what? Weakly, weakly repaired by by a magnet. Good. This man is weakly what? Repaired by what? By a magnet. Assume this is a what? A magnet. See, this is also what? Magnet. And in front here, let me use this green marker to represent what? Diamagnetic. An example of diamagnetic is gold. Yes, example of diamagnetic, we have what? Gold. Let me say this is a what? A gold. And this is what? What? Magnet. So between them now, the force that we experience between them, the force that we experience between them here is a repulsive force. What did I call it? The force here is what? Is repel. So the diamagnetic substance, they are weakly repelled by magnet. Example, we have good example of diamagnetic. We have copper and we have silver. Hydrogen, they are diamagnetic. They are weakly repel a magnet. But in terms of what? Or para, what happened to para? Para here, they are weakly attract. Weakly are what? Attracted by a what? Magnet. So this one is repelled by a magnet. So if we have a magnet here, like this, and this represents paramagnetism, this green marker, a sample of paramagnetism, we have aluminium. Let me see, yes, we have what? Aluminium. So this place is what? Aluminium, aluminium, and here is what? Is magnet. So the weakly attract. So this thing we what? We move toward the what? Magnet. Abi, this is what we call what? Attraction. So here we have what? Attract what? Attraction. But in case of Vero, this one is weakly repel. This one is weakly attract. This one is what? They are strong. Only what? Attracted by a magnet. Can you see it now? So this man is what? Is strongly attracted by what? By a magnet. His own is what? Is strongly what? Attracted by a magnet. And here we have a ferromagnetism. Example of ferromagnetism, we have iron. Example, we have what? Iron. So this is an iron. This is a magnet. between them is a strongly what? Attracted. Strongly attracts. What is diamagnetism? Dia are weakly repel a magnet. Para weakly attracts. Vero strongly attracts. That's the first definition of the three of them. The next thing is what? Next one is, we can say, mm, okay, this one is they are weakly magnetized. Maybe not magnetized in opposite direction of magnets of magnetic field. They are weakly what? Attraction in opposite direction of what? Of magnetic what? Magnetic field. Look at this here. If this is magnet, and the field that the magnet produce is this. This is magnetic field. So this is what? Magnetic what? Magnetic field. This is what? Magnetic what? Magnetic field. So diamagnetic. This is dia what? Magnetic. The diamagnetic we have here, this is it. They are weakly magnetized in opposite direction. So the direction of what? Of this field, of this diamagnetic, it will come like this. So this is what? This is the what? The magnetic substance. This is what? Magnet. That is, during magnetize, the direction of the magnetics is opposite direction to the what? Direction of magnetic what? Magnetic field. So here, what happened? They are weakly what? Magnetized in the same direction with magnetic field. This one, they be what? They are weakly, they are what? Weakly magnetized, magnetized in the same direction of magnetic field. So for this scenario now, this is the direction of what? This is the magnet. And this is the what? Paramagnetic substance. So direction of magnetic field is this. So direction of paramagnetic substance is also this. This is para what? Magnetic. This is the magnet. So the paramagnetic, they weakly magnetize in the same direction with magnetic field. But dia weakly magnetize in opposite direction of what? Of magnetic what? Magnetic field. So here, this one will be strongly magnetized. They are what? They strongly magnetized in the same direction of magnetic field. So, if this is the magnetic field in this form, this is the magnet, and here we have the ferromagnetic substance. This is the direction of what? Of magnetic field along this direction. The direction of this ferromagnetism is strongly the same direction with this. This is ferromagnet. This is what? Magnet. Direction of ferromagnetic is the same thing with direction of what? Of magnetic field during magnetization. I tell you the meaning of magnetization before. Good. So the next one here is if the magnetic substance is suspended in a uniform magnetic field. If the magnetic substance is what? Is suspended in a uniform magnetic field, hmm? Magnetic field, then slowly align in perpendicular per what? Perpendicular direction to perpendicular direction to magnetic field. Look at this aspect. Okay, now, if this is the what? Magnetic bar. If this represents magnetic what? Bar. This is magnetic what? Bar. And don't forget that this side is north. And this is what? South. And we have a magnetic what? Field coming from what? North into what? South. This is magnetic field. So if you now place the what? A diamagnetic material in this field, The diamagnetic material will what? Will align himself perpendicular to the direction of the field. That is, this man, it will what? It will be upright, what? Perpendicular to the direction of the what? Of the field. This is what? The magnetic substance. So when the magnetic substance plays in a uniform magnetic field, it will form a perpendicular to the magnetic field. This blue line represents magnetic what? Magnetic field. But here and this side, they will form a what? A parallel. Let's see it now. If paramagnetic substance is suspended in a uniform magnetic field, then slowly align in parallel direction to magnetic field. So this one will what? Let me use Galadscienceacademy for bar. This is what? Magnetic bar. And this is also a what? A magnetic what? Bar. Here is north. Here is what? South. And the field is coming out from here. It's a uniform feed. If it's uniform feed, be in straight what? Line. Mm. Mm. Yes. If I now place what? Paramagnetic into this feed, it will align himself in a what? Parallel. This is what? Paramagnetic material. The same thing happened to what? To Vero. If ferromagnetic substance is suspended in a uniform magnetic field, then slowly align in parallel direction to magnetic field. By doing that too, we have N and we have south. So this is the direction of the what? Of the field. And this paramagnetic too also form a what? A parallel. The ferromagnetic to the what? To the field. And the next one, or I call it what? The last one is, or before the last one, and the last one, in non-uniform magnetic field. In what? In non-uniform magnetic field. In non-uniform magnetic what? Magnetic field. The magnetic substance or material move from stronger to weaker field. From stronger field to weaker field due to repulsion. Look at this field. These three fields here, they are uniform. But in case of what? Of non-uniform field, see, this how non-uniform field look like. Eh? This one is what? In a straight line. This one is coming like this and a deviate upward. Is it in a straight line? This one will also come in like this and move downward. So this kind of feet are called non-uniform feet. Everything supposed to be in a straight line. So this one that is uniform here, this side are called strong feet. This side are called weak what? Weak feet. This place we call it what? Strong what? Strong feet. Are called strong feet. So here are called what? Weak field. So the diamagnetic, they move from strong field to what? To weak field. If I place diamagnetic here now, diamagnetic, assume I place it here. So they will what? They will move. If I place it here, they will move toward the side. This is direction. Why? From strong feet to weaker feet. But in case of what? Of this one, if in non-uniform feet like this, in a non-uniform what feet, this paramagnetic, they move from what? From weaker to what? To this is non-uniform feet. You can see that the field line will behave like this. The field line will behave like what? Like this. So this side, I said it. This side is called what? Weak field. This side are called what? Strong field. So if you now place what? Diamagnetic, no, paramagnetic, yeah. So the paramagnetic always move from what? If you place them here, they will move. If it's para, we have there, the para will move from what? From this side, from weak feet to where? To strong feet. The same thing happens to what? To ferromagnetism. So ferromagnetism, if you place it in a weak, in a non-uniform magnetic what? Magnetic field like this. So they also move from where? They move from weaker field to they move from weaker field to stronger what? Stronger field. You know, I said this side is what? Is strong field. Here is what? Is weak field. So the last two aspects of this differentiation is Let me add it to it. The diamagnetic substance, their what? Their magnetic substance lose their magnetism on removal of magnet. That is, this diamagnetic substance, that is, they are temporary magnets. Real what? Magnets that they lose their what? Magnetism easily. Where what? The paramagnetism. This one is also what? Paramagnetic substance lose its own what? Their magnetism on removal of magnets. I've explained this before. So this is also what? Temporary. But this one, ferromagnetic substance does not lose their magnetism on removal of magnets. That is a permanent magnet. Example of this, let me add this example here. Example of this ferromagnetism, we have iron, we have alkali metal. Alkali what? Metal, and alkali earth metal. Yes, but example of ferromagnetism here, I said we have what? Aluminium. This one we have gold, silver, and copper. So that is all about what? The differences between paramagnetism, diamagnetism, and ferromagnetism. But in terms of what? Magnetic susceptibility. So this paramagnetic susceptibility, the paramagnetic susceptibility for this one is less than what? Is less than 0. Susceptibility is what? Less than 0. For this magnetic susceptibility for paramagnetic is what? Is greater than what? 0. For this ferro is greater than what? 0. So that is all about what? Magnetic substance. But lest I forget, let me add this term to it. Look at this term. Twin. What is meaning? You may ask. This is the process of converting magnetic powder into the what? Into the solid form. You know, if you have what? Magnetic what? Iron powder. We have iron powder, convert it to what? To iron solid. You know, this iron powder can call it what? Iron filling. So the process of converting the powdery form of a magnetic substance into the solid form, we call it what? Stirring. So that is all about magnetism for this level. So in my next class, I will start from magnetostatics. Magneto what? Magnetostatics. So, you know, we have electrostatics. We also have magnetostatics. So from this magnetostatics, I will now move to the what? Magnetic field. So after magnetic field, I will now move to what we call what? Next topic is magnetostatics and magnetic field. After that, on to what? The magnetic field generating from current carrying conductors. So here we explain the what? The Flemings. No, the Maxwell come right answer, and we now move. We talk about what? The Ampere's law and Balsavant's law. So thanks for watching.